So welcome everyone to the SoundTube webinar series. What we're planning on doing is holding a series of webinars, and each one will be either a training experience or an introduction to a new product. And keep going, Mike. Back up. So we'll be doing product overviews, training, as I said, new products, and we'll try to hold them, I believe, once every month to 2 months. Okay. So the agenda for today is on the IPD-Hub 2. You can read the agenda yourselves, but basically what we want to do is, there's a lot of misconceptions with the Hub 2, so we want to try to get everyone to understand how to use it, but also what applications it's useful for. And at the end, we'll give a couple of examples of how you might want to use it. But to get started, I'd like to give you a little bit of history of how we got to the IPD-Hub 2. So back when we first introduced IP-based PoE speakers back in 2012, and it's like we were the first. We created the category, and now there's other companies jumping in, but we're still by far, we have the most models on the market right now. And we also have the most experience, and we're probably the largest in it still. But back in 2012, when we first introduced it, we introduced it based on CobraNet, not Dante. And for the reason for that was Dante was just starting out. There was other formats like AVB, but there was no clear indication of which format would be the dominant format going forward. CobraNet had already been on the market for a number of years, so we decided we'd go with CobraNet. And we knew that CobraNet was going to go away in a matter of years, but we at least wanted to do that to get into the business, and we designed our boards in such a way that all we had to do once the dominant transport, let itself be known, we would just switch to it. So in 2012, we introduced the IP-based speakers, which were the same as our IPD speakers, but they were CobraNet. Then when we started going around and introducing it to consultants and integrators, the first question that everyone really asked, or the main question everyone asked, is how does it compare in price to a regular 70-volt system? And oops, I just realized my camera's not on. Here I am. So, and the answer to that question was it's more expensive, but it gave a lot of options to integrators and consultants that they didn't have now based on 70-volt systems. And so the early adopters were really more of the IT-based systems or IT-based integrators and consultants. And the reason for that was if you talk to an IT-based guy and you told him the price of the switch, you told him the price of the speakers, it was comparably very cheap to an enterprise-based network. And it gave them control of the audio. So they were the early adopters. They really liked it. But we still got the question on most of the conventional companies, it's more money, why should I do it? So we introduced the IP4 series of products. And what that was, for those that aren't familiar, is it's a master-slave configuration where you have one speaker that's hooked up to the network and 3 additional speakers that are connected to that one master speaker. And by doing that, we cut the cost of entry by half. So if a speaker was retailing for, let's say, $550 for an IPD speaker or an IP speaker, and then you times that by 4, you'd be at $2,000. If you did the IPD4 series of products and cut it in half, and you had a 4-speaker system for $1,000. So cut the cost in half, got it very close to a 70-volt system, but we were still more money. So we decided to brainstorm how we could bring the cost of an IP-based system from a little bit higher to the same or lower cost than a conventional 70-volt, 100-volt system, distributed audio system. And that's where we came in with the Hub 2. So the IPD-Hub 2 was designed we had to rethink how you designed a system when we did this. So conventional systems use what we call a centralized DSP. So everything, you have a DSP and your input devices go into the DSP. All the outputs come out of the DSP. All the control devices go to the DSP. So everything comes to this centralized hub and moves out from there. The idea behind the IPD-Hub 2 was we would decentralize the DSP. In other words, go from a single unit to a lot of units, almost like a mesh network, where all the Hub 2s talk to each other on the network. And if you assign them into a zone, they all do the same thing. So if you raise the level, lower the level, it all happens to all of them on that zone. If you change the input, it all happens on that zone. And by doing that, we cut the cost greatly down for entry into a network-based system. So now with the IPD-Hub 2s, you can get anyone on a network. Anyone can get on a network-based, totally network-based system for the cost of a conventional system. And we'll show you that at the end, how it works out numerically. So with that, I am going to turn it over to Mike Jania, one of our engineers, who's going to actually show you and take you through hookup, connections, and functionality of the IPD-Hub 2. Mike?
Thanks, Ken. So like he said, I'm going to kind of walk you through how to actually use the Hub 2 both physically and in software. It can seem pretty daunting at first, but hopefully by the end of this, you'll kind of have the tools you need to understand how to actually deploy something like this and see where it might fit into different kinds of installs that you might be interested in. So the main thing that we want to kind of get across here is that this is not just a Dante amp where you send a Dante audio signal into a regular power amplifier and it spits it out to traditional speakers. What really sets this thing apart is that little yellow control and local input port here. That's really the heart of the system. So what that can be used for is you can send a local input using an input device, kind of like an RDL format A sender, which will connect to the Hub 2 with a special adapter cable that we provide with every Hub 2. It's included. And what that does is it converts the RDL's twisted pair A to the B and C of the Hub 2, so that it essentially just adapts it so that you can use it with our product. What you can also use this control and input port for is for volume control. But here first, I'll click through a couple different types of these input devices. They have all kinds of different connections: Bluetooth, XLR, RCA, stereo mini, things like that. So like I said, you can also use a volume control with it. This is our SoundTube RVC1. It's got an adjustment knob on there, and then it also has an A and B selector switch, and it just connects with a standard network cable. There's an output jack on the back of the RVC, and you connect it straight to the Hub 2 just with an Ethernet cable. You can also run an input device into the input side of the RVC, so you can use them concurrently. Like I said, you can toggle between two presets using this preset selector switch. So option A is your default preset, and option B can be set in the preset assignment section of the Hub 2. We'll get to that a little bit later on. So you can choose between two, and then with other control systems, you can make use of all 9 presets that the Hub 2 allows. So first, we'll get into how to set it up physically. It's fairly straightforward. The software is really where this thing shines. But as you can see on the left side there, you've got 2 speaker outputs. They're 8-ohm speaker outputs, meaning you can wire 2 8-ohm speakers to it, or you can wire 4 16-ohm speakers in parallel. And they wire just with standard speaker wire like any other system you might do. Next, you route an Ethernet cable to the Dante input. And so that's where you send your Dante audio and your PoE from any network or PoE switch. And if it's an older network switch that can't provide PoE, or if you just don't want to use PoE with it, you can use the 24-volt DC barrel input or the Euro input. But those are obviously optional. Most installs just make use of PoE. So now we'll get into the software side a little bit. So when you connect the Hub 2, there's 2 main softwares that you need to use to set it up. So we've got our SoundTube STNet Control Center software, and then Autonate's Dante controller software. So STNet Control Center is used for device setup and configuration of your individual Hub 2s, while Dante controller is used for the audio routing of the whole system altogether. So within STNet Control Center, when you open up a device after you've connected it, it brings you to this configuration page. And so we're on the DSP setup tab.
Michael, real quick, sorry to butt in. There's a question, will it work with a 4 ohm load?
We don't recommend it. So it is an 8 ohm speaker output. The lowest we really ever suggest is like a 6 ohm load, but anything below that, you kind of risk overcurrenting the switch.
Yeah, let me, Mike, let me jump in and also answer that question. So if it's a true 4 ohm load, it will work, but your output will be lowered. You won't get as much level out of it. If it is a load that drops below 4 ohms, then Mike's correct, it will overcurrent and the PoE port will drop out.
Thank you.
All right, so back to the DSP setup window here. So on the left, you've got your input gain fader. So this is the actual level that is adjusted with the use of a volume control. It's not necessarily the output. And the reason for that is because we've got this output gain fader over here on the right. This is the level that you can set for your paging priority. And that is static and is not affected by adjustment of the RVC. And the reason for that is because if you have paging audio come over the network, you don't want that RVC to mute it. I mean, it's paging for a reason, it's important. So the RVC can adjust your main program audio through the input gain, while the paging audio will defer to the output gain and will not be affected by adjustment of the RVC. So then between those two, we've got our 8-band parametric EQ here. You've got high pass and low pass filters as well. So you can really set exactly how you want each speaker to be configured. Now we'll jump a little bit into the DSP setup and control, and this is really the bread and butter of the system. It's by far the most important part, and it's really what allows us to do, as Ken said, to build out a system using this device that can compete with the cost and exceed the performance of a traditional system. So we'll jump into the left side of the window here. Under here, you've got the enable channeling button. So checking that essentially just groups channel 1 and channel 2 and joins them so that you can configure them as one. You can configure them individually if you have 2 or 4 speakers and you want to put them in separate zones, I guess. But generally they'll be grouped together because they're most likely in the same room or zone. So beneath that, we've got our quick mix controls. And so under quick mix, this is where you will select your main program audio input. So this is typically whole house music or whatever you want to be your primary audio rather than your paging. So in this particular configuration, we have our Axiom 1 source checked, which means that our local input channel 1 will be our primary audio. Now down below, underneath paging priority, this is where you'll set your paging source. So you can see that we have Dante RX1 selected. That's a remote source, meaning that it is audio being sent to the hub over the Dante network. And so that actually is a twofold process. It needs to be set up in the STNet Control Center so that the hub knows to use that channel as its paging source. But you also need to set it up within Dante controller so you actually have audio going to that as the receiver. Underneath that, we've got our Ducker controls. So the release is the time that the paging audio must stay below the threshold level in order for the Ducker to deactivate. The threshold is the level that the paging audio needs to be for the Ducker to kick in. And then the depth is the level that the program audio will lower by when the paging audio kicks on and the Ducker activates. So just to kind of go over one more time, these quick mix and paging priority sources. So your Axiom 1 and your Axiom 2, those are your 2 local inputs. It can be channel 1 or channel 2, depending on the type of connections you have on that input device. For example, some of the Format A senders, they have an RCA one that the left channel is your channel 1 and the right channel is your channel 2. Some of them have Stereo Mini as channel 1 and an XLR as channel 2, things like that. And those can be chosen as either your quick mix source for your main program audio, or they can be set as your paging audio. And then you've got your Dante RX channels. And like I said, these are what you actually need to set up as a flow within Dante controller. Those again can be used as quick mix or paging priorities, so they can be your program audio or the paging audio. And so within Dante controller, you can see here that the Hub 2 actually comes up as both a transmitter and a receiver. It comes as a transmitter because any audio forwarded to the Dante network and sent out like it's a transmitted audio source. And then it also shows as a receiver so that you can route audio to those Dante RX1 and RX2 channels. So now we'll get into the matrix mixer a little bit. So in that same section we were just in, you can see that there's that little checkbox next to enable matrix mixer. So when that's not checked and you check any of these boxes under quick mix or paging priority, having it checked turns the matrix mixer knob to its maximum, and having it unchecked turns it to its minimum. So there's obviously going to be situations where you might want to truly mix in your audio and use multiple sources. And so that's when you'll check that matrix mixer box. And that enables the matrix mixer tab on the left there. So within that, you've got your actual mixer controls. You can adjust your levels from source 1 and source 2, and so on and so forth. So then the next tab over is our amp setup tab. So this has a number of other configuration options. We'll try to walk through them here kind of one by one. So your power mode, this shows that we're connected to a PoE plus switch. It will also connect, like I said, to DC on those optional inputs or just regular PoE. That 40-watt enable checkbox is only possible with our SoundTube STNet switch too. Without our switch, PoE plus would be capped at 30 watts. Beneath that, we've got our impedance monitoring. So this will actually check the status of both the woofer and the tweeter and report back a failure, or if it's beginning to fail. It is important that you actually have that checkbox selected next to each speaker if you actually want it to monitor. We've got a pink noise generator so that once you wire your speakers, you can generate pink noise and use that for testing, troubleshooting, making sure your wiring and connections are all secure, things like that. And then we've got our RVC setup, our zone assignment, and our preset select. These kind of go hand in hand. So like Ken said, with the zone assignment, you can group multiple hub 2s in a particular zone, and that will allow them to essentially operate together as far as RVC adjustment goes, preset select, things like that. And then down under preset select, if you check that enable box and then select a preset next to preset assignment, that is where you would allow the toggling of the A and B switch on the RVC to actually flip between the default and then the selected preset. And then under RVC setup, that's where you actually calibrate it. So once you click that calibrate button, so this is how it connects through the output. Once you click that calibrate button, it'll ensure you have it installed, just connected with a regular network cable directly to that yellow input port. It'll ask you to turn the RVC knob fully clockwise to the maximum position, turn it counterclockwise to the minimum position, and then it will save the calibration. Once you've saved your calibration, we need to choose which output we want to assign it to. And so under this drop down here, you can either assign it to amp output 1, amp output 2, or both amp outputs. And really what the RVC does is it controls that input gain, like I said before, so that it doesn't adjust the paging volume. But as far as this goes, it is the output on channel 1 or channel 2. So a lot of times, if you have 2 speakers, it's most likely going to be connected to both amp outputs. Once you've made all your changes on this page, it's very important that you click the Save Settings button in the top of the window. That will ensure that in the event of a power loss or a system reboot, that when the Hub 2 reboots, it will maintain the configuration you just set. You don't want to have to redo it every time the Hub 2 boots up. So now we'll get into the zone assignment a little bit. So Ken kind of touched on this before, but essentially the zone assignment allows you to group Hub 2s together and use a single RVC to control all of the IPD Hub 2s in a particular zone. And kind of along those lines, we also offer the IPD-Hub 2 extender box. And what that does is it allows you to send the same local audio to multiple Hub 2s within a zone. It can pass the same audio up to 5 Hub 2s. And if you need to send it to more, you just need to use more extender boxes. But you can see here on the far right there, you've got a main in port. That is where you will route the RVC to. And then from the main out port, you will connect another network cable to the control or input port of the Hub 2, which the RVC is calibrated to. Then on the extender output 1, 2, 3, or 4, that's where you connect it to any other Hub 2s you have in that zone. And so what you can do with that is when you go into your presets, you can actually save it as a preset and then load that same preset onto the other hubs. And so that will help to group them all together. So now we'll kind of touch on a real world scenario where you might use some of these features that the Hub 2 can provide, and real reason why we created this thing. So we'll go over kind of a classroom setup. So within this classroom, we've got an STNet switch somewhere centralized in the school. We've got our IPD-Hub 2 in this particular classroom. The switch is sending Dante and PoE to the Hub 2's Dante input. And then we've got two ceiling speakers wired with speaker wire into the classroom. In addition to that, we've got an RDL Format A sender and a SoundTube RVC1 volume control so that the teacher can put a movie or music or show videos or whatever they want to do on it. And then what we can do is use a secondary Dante input for paging audio. And so the intercom, if they need to call down to the particular classroom, that will duck out the movie or music or whatever the teacher might be showing. However, because this is a school, they're most likely not running Dante. That's not a problem in this case because you don't necessarily need to use Dante. You don't even need to use PoE. So you can connect it just to a standard network switch and use the optional 24-volt DC input to power the Hub 2. In this configuration, you won't be able to send paging audio over the network because you're not using Dante. But by using a 2-pair sender with the RDL device, you can set your input channel 1 under the quick mix there to be your local input channel 1. And that will be any audio that the teacher wants to connect. They'll use that left input on the RCA there, whether it's a movie or music or whatever they want to show. And then for our paging priority channel, we'll use our local source input channel 2, which will go to that right RCA. And so that will be connected to the intercom system or the paging. And that effectively accomplishes the exact same thing as if it were on the Dante network. You just use your paging priority as a local source rather than a remote source. And so now, if you want to get some more information on how to really get into the nitty-gritty of this, next week when we send out our follow-up email with the webinar recording and all that, we will also include a link to a new video that goes over how to set up a complete restaurant system with 5 zones, multiple local inputs, and it will really touch on all of the things that the Hub 2 can do. And in addition to that, we kind of wanted to break out what the cost comparison might be to set up this restaurant system with the Hub 2 versus what it might look like as a conventional 70-volt system with centralized DSP. And so with that, I'll turn it back to Ken if he wants to touch on the cost a little bit here of the different components and how they compare with the fully networked system versus the traditional system.
Thanks, Mike. So as you can see in the bottom line here, it's virtually the same price as a conventional system, but you get an additional functionality of monitoring, remote access, a lot of the same advantages of the regular IPD stuff you get with the IPD-Hub 2. In fact, you get all the same advantages. So, if there is an issue on the system and you're sitting in your office, if you have access to their network, you can jump on and take a look and see what the problem is and remotely troubleshoot it. With a conventional system, you just can't do that. But you can see that the traditional system has a regular 4x4 DSP, which means that's only 4 zone. With our restaurant system, we actually have 5 zones. So it doesn't cost much more to add more zones with the IPD-Hub 2, but it does cost quite a bit more to add them with a conventional system. So just a traditional 4x4 DSP, a 4-channel amplifier, volume controls for each zone, same speakers, same input device, Bluetooth input device on the thing, and a network switch, same network switches in both. So we did it. We accomplished what we set out to do. We got a network system for basically the same price or less than a 70-volt system.
All right, thanks, Ken. So finally, I just want to touch real quickly on the engineering support that we offer. We've gone over this several times, but we just really want to hit it home that our engineering team here is a resource to be used. We offer full ease layouts for any kind of commercial installs you might be doing. We can help place speakers in a given room, a full building with multiple rooms, anything like that. We're pretty flexible. We prefer to work with architectural drawings, but we can work with something as simple as a napkin sketch, or even just a, hey, this room is 20 feet wide and by 35 feet long, anything like that. We are as hands-on or hands-off as you might want. If you want to tell us what speakers you want, how many you want in this room, where should I put them? We're happy to help you with that. If you want to throw us a drawing and say, I have no idea where to start, can you help me get going in the right direction? We can help you with that as well. All you need to do is send an email to engineering@mscaudio.com with some information, details on the project, anything like that, and we will be happy to help you out. And with that, we will open it
Hey,
up.
Mike?
Yep.
Yeah, I have a question.
Sure.
When you were talking about the RVC, is there a way to set a range of volume values so it doesn't get too loud and it doesn't get too low?
That's a great question. Ken, can we do that?
Yeah, so you can do that on the output gain. So the output gain isn't affected by the RVC. So you can set a max limit on the output gain so that you can't turn the volume up past whatever point that you want it to be turned up to.
So yeah, so you can
Okay.
set a max limit, or theoretically a minimum limit, but you can't hone them both in separately.
Yeah, anybody, if you have questions, please put them in the chat and we'll try to answer them.
Looks like we had several people say good morning, and that's all the questions we've got, other than the 4 ohm load, but we answered that one already.
Okay, then if there's no more questions, I guess we'd like to thank everyone for joining us. We hope it was worth a half hour of time, and if you do have additional questions, you can just reach out to us and we'll be happy to answer them at any time. So with that, I guess we will conclude our webinar. Thanks again, everybody.
We did have a question about, can we get a copy of the PowerPoint? We will have that recording available.
Yes, we will be sending out a follow-up email, I think sometime next week, probably before the holiday, with some follow-up. We'll include all of the questions that were asked live or in the chat, answers to those questions, as well as the recording of the webinar.
We did get one other question. And I think I'm going to need a little more, a better way to ask the question, because I'm not sure I understand it. And it's, I didn't understand looping. Can you type in what you mean by looping? It's probably a word we used, but I can't get the context on it. Oh, I gotcha. So what that means is that when you connect amplifiers in a zone, Mike, can you bring up the zone page? So when you assign an amplifier to a zone, let's in this case zone 3, each amplifier can be assigned to a zone or the same zone. So if we have multiple amplifiers assigned to zone 3, they all talk to each other. They all react the same way. Then go to the extender box, please. So the extender box, so if you have local audio and you have multiple amplifiers in a zone, you need to go through the extender box. So you would go from the RVC into the extender box, and then you would come out of the extender box to each of those amps in the zone, and that would loop the input audio from the local input, from a local input, an individual one, to all those amps in the zone. So in other words, they don't pass audio on the local input, so you have to connect them all up together using the extender box. Does that answer that question?
And any other questions?
Got it. So
So the extender box does not need power. It's a passive device. So it just passes the power from the Axiom port to all the devices on the extender box.
All right, any more questions before we wrap up?
And again, if you think of something, or if you want to try out using the IPD-Hub 2 in an install and you're not exactly sure how to connect everything up, please, get in touch with us. We'll be happy to design the system with you. Okay, I guess we're going to call this one to an end. Again, we appreciate everybody joining us, and have a great weekend.